Hello everyone, I'm Priya, Technical Marketing Engineer from the Aruba Switching Business Unit. Today we are diving into what's new as a part of Client Insights in the AOS-CX 10.16 1006 release update and how it's changing the way we troubleshoot network issues on each stage. And as we go through this feature brief, we will also see a quick demo and further details about this feature. So with AOS-CX 10.16 software release, we now get deeper visibility into one of the most critical parts of client onboarding, which is ARP to default gateway latency and failure metrics. So let's deep dive into the feature. So the Client Insight feature monitors onboarding across L2, L3, and L4 layers, where L2 being client authentication or authorization, it can also be an open port, and L3 being IP acquisition via DHCP process using the DHCP snooping. And L4 is the DNS onboarding or latency. And now the new addition to this is ARP to default gateway latency and failures on per client basis. And this is supported only on IPv4. So ARP latency is measured per gateway IP using request and response timestamps, and failures are logged with the reason code as well. So this is how the feature basically works. So let's talk about the use cases of this feature. So this feature is very helpful to validate client onboarding health at every stage. And it also provides a view of which client connects, how often, and through which gateways. Using the ARP to gateway, that is the default gateway latency and failure metrics, it can also detect performance degradation way before any impact, and thus it also reduces the MTTR. So few customer benefits of this feature are obtain deeper insights into client behavior across all onboarding layers. It also enables early intervention for performance degradation and avoids looking for client data in multiple places. And finally, it increases visibility into the device behavior at the network edge. So the supported platforms are listed here. It's the 5420, 6200, 6300, all versions. And it's also the 6400 and 6400 V2. So that's a quick intro about this feature. And to the left, you see a picture here, and I have described how to enable the feature, how to view the client details, and how to troubleshoot this as well. So let's go through this part now. So once a client onboards, it can either be successful, it can either be partial, or it can also time out. So depending on these three states, we'll talk about the ARP to default gateway latency and failure. So in order to enable this feature, we need to make sure that client insight is enabled, and we'll also have to make sure DHCP v4 snooping and snooping static attributes are also enabled as a part of the CLI. And to view the client details, you can get into the diag mode and issue the command of diagdump client insight basics. And finally, to troubleshoot, you have to enable client insight event logging, and under the client insight event log, you have to enable client onboarding too. So finally, you can also use the show events-c client insight to see the logs for this particular or any particular client that onboards. So here is a snipped output or an example of how a diagdump output looks in case of ARP to gateway onboarding, latency and failure. So here I have provided an example for a success case. So as a part of L4 onboarding, you will see ARP to gateway details, and if it's successful, failure, or it's timed out, and you will also see the gateway IP, the gateway through which the client comes into the network. So that's the gateway IP here, that's the default gateway, along with the onboarding latency. Here it's 4759 microseconds, and the request and the response time. That is the ARP request and the response time as well. So as I already highlighted, we have three different states: successful, failed, and timed out here. So let's move on to the next slide. So client inside details like IP address, DHCP and DNS resolution are available as consolidated data for Aruba Central Conception. So currently, ARP to default gateway resolution, latency and failure details are not supported in Central yet. And this ARP latency calculation only applies to ARP requests sent to the default gateway. It does not include ARP requests sent to other IPs on the network. So for ARP to gateway latency to work, DHCP snooping static attribute caching must be configured. And it will be a part of L4 onboarding in addition to DNS onboarding and latency. In case of DHCP server is not configured with default gateway settings, our onboarding status will report as failed in overall onboarding event. Onboarding details are captured only for those clients that onboard the switch after enabling client-inside configuration. And this data will not be available or published for existing clients before client-inside feature enablement. So it is at most importance to enable the client-inside feature before you onboard your client to see the other details like request response and timestamps. So this is one main detail to be noted of. So there can be multiple onboarding event logs for a client if the client MAC ages out and rejoins repeatedly. So it must initiate, that is, the client must initiate request to the default gateway to see the onboarding latency details again, else it will result in a timeout state. If the default gateway is the immediate switch connected itself to the client, then a default value of 1 millisecond will be updated as the ARP to gateway latency. And this feature is not inherently tied to switches acting as gateways. It can work with any device that functions as a default gateway. This can include switches, mobility gateways, or potentially any other type of gateways. And finally, this feature is not supported on ROP and lag interfaces. So let's talk about the platform support on a broader level and in comparison with L2, L3, and L4 states. Because this enhancement is a part of L4, I just wanted to give a comparison across L2, L3, and L4 onboarding stages. So the platforms that support all the three stages, that is port access, DHCP snooping, and as a part of L4, both DNS and ARP to gateway latency are the 63 and 6400s. And on these platforms, below telemetry details will be available, ranging from the authentication latency, DHCP latency, failure states, onboarding events, and then ARP and DNS latency and onboarding. So all these details can be seen in these two platforms. The other platform support across the stages are also listed here. Please refer this table.
Let's talk about L4 overall onboarding status and failure codes. As we already saw in the initial slide, we had three possible outcomes for L4 onboarding. So which is successful, failed, and timed out. So in case of successful, the ARP to default gateway exchange is successful and all good. So in case of failed, we see that the ARP to gateway exchange failed with no response received from the default gateway. Whereas in timed out, the ARP traffic is not initiated from the client itself, and hence it times out. So here is the comparison across again L2, L3, and L4 and the overall onboarding status and how it is decided as per each onboarding stage. So I'd like to highlight here, what I'd like to highlight here is that the partial state occurs only during incomplete L2 or L3 onboarding. You wouldn't see that in L4. And in case of failure and timed out, we prioritize failure or timed out case from any stage for the overall onboarding result. For example, in this table from the bottom, the last two states, that is L2 partial and L3 failed, we prioritize the failed state. Same is the case for timed out as well. Partial and timed out in the next row, we prioritize timed out as per the description. So the overall onboarding priority is going to be L2 onboarding state followed by L3 and then L4. So moving on, we'll talk about each of these states during ARP onboarding. And the first state is L4 state, which is successful. So here I'm just showing this output using the diagdump client insight basic command. And you see that it is successful. That is the overall onboarding status is successful. And here is my L2 onboarding details. So I have used MAC, auth, and I'm also seeing my L3 onboarding detail here along with the IP onboarding and the latency and on which VLAN it is in. So these were all already existing. So the ones that are highlighted are the newest ones. So L4 onboarding details now along with DNS also has ARP to gateway details. And you'll find the gateway IP here along with the request and response time as we already saw. So next is the L4 state failed. So now let's say the R2 gateway onboarding failed. You see that on your right, the ARP onboarding status reflects failed and the failure reason, because we already said that the failure reason will also be logged along with the status. So the failure reason here is that the client did not receive a valid ARP response. And you see the gateway IP listed here along with the latency being null because it hasn't received any response. So it is null here. So is the response time and only the request time is populated. So in accordance to this, if you see the overall onboarding status, that is also marked as failed, stating the reason that L4 onboarding failed. So that is how the output looks like when the L4 state fails. So now the next one that we jump to is L4 status timed out. So now let's say the ARP onboarding status reflects timeout on the L4 onboarding details. And the failure reason here is client did not initiate an ARP request to the gateway. So in these cases, you will see that there is no gateway available in the L4 onboarding detail. And your overall onboarding status reflects timed out, but it will still call it out as L4 onboarding failed rather than timed out. And one other thing to note here is that the onboarding timed out value is 2 minutes. So anything after this times out if it doesn't receive a response from the gateway. So let's talk about ARP latency and onboarding REST API. So this API lets you pull detailed client onboarding data on ARP onboarding and overall status information. You can also check information on the DNS onboarding and per VLAN client insight details, followed by L2 and L3 details. So this is all under the Get System Client Insights endpoint. So we'll also talk about few troubleshooting commands to help us troubleshoot in case of any failure or timeout. So to enable generating event logs to publish the onboarding status of each client, we'll have to use the client insight event log client onboarding command. And in order to see the logs, you can use the show events client insight. And this is how the logs are published for the clients that are onboarded on VLAN 20 and the respective ports, and in case of success, failure, and timed out. And to check the maximum client limit, we can use the show capacity status client insight client limit feature. So it will tell you the number of client learned by the client insight feature with the values currently configured and the maximums. And next is the debug commands. So we can use the debug client insight all and the debug destination buffer or console or syslog along with the severity that you want to check on. And finally is the diagram client insight basic, which we already spoke about to see the client onboarded output. So I will also show you a quick recorded demo of this feature. And here is a configuration reference that you can take a look at. So I have a 6300, which would serve as my gateway, and a 6200, which is an access. It will talk to my endpoints. So let's take a quick look at the demo. So in my 6300, I have gateway IP configured. So I will have interface VLAN 20 along with 20001/24. So it also has downlinks connecting to 6200. So on the interface 1/1/48, I have VLAN access 20. And following this, we'll get into the 6200 and we will see what are all the configurations pushed in here. So I'm going to have two clients here, Windows and an Ubuntu client. So on my interface one, I have a DHCP server, which is also allowed for VLAN access 20. And I have DHCP v4 snooping and static attributes enabled for it to cache. So that is enabled already. And I've also enabled snooping on my VLAN 20, followed by my clients, where I have VLAN 20 access as well. And the last one I'd like to talk about is this is the uplink to my gateway. So I have 20 there as well. And the client inside enable feature along with the event logging has been enabled here. So now when I do the show MAC address table, I don't have any clients onboarded yet. So now we'll see how we configure the DHCP server, and then we'll come back to the switch. So here I have a new IPv4 scope assigned, and I'll be assigning IP addresses of range 20.00.30 to 40 to my clients. So this is the IP address assignment from 30 to 40. So all my clients are going to take an IP address between this range. So from the Windows client, let's see if it's able to talk to a DHCP server on this network. And it will also check simultaneously for the Ubuntu server as well. So I'm just trying to ping my gateway and see if this is reachable to, I mean, the client is reaching that gateway. And so is the case for the other client as well. I'm trying to request a DHCP IP, and I will try to also ping my gateway 20.0.0.1, which is resting on the 6300 switch. So you see that it receives an IP of 20.0.0.31, and for my Windows, it was 20.0.0.30. And my DHCP server is on 20.0.0.10. And we also see that it's communicating to the gateway. So now let's get back to the switch and see the MAC address table, and we will see that both the clients have been onboarded on 1/1/2 and 1/1/3. So now we will look at all the client onboarded data for these two clients, getting into the diag mode. So the diag client inside basic command would be used here, and you will see both the information for you'll see all the information for both the clients. So my Windows client and my Ubuntu client both. So the first one is this client, which is my Ubuntu client. And I see that L2 onboarding is successful and the overall onboarding is successful too, because all three states are successful and we don't have any failure or timeouts here. And you can see that on VLAN 20, the DHCP details as well, that is the IP onboarding details to IPv4 onboarding details only for now. And the client IP and the server IP along with the DNS IP. And that's our area of concern, that is the L4 onboarding detail. You will see the gateway IP along with the latency, request and response times for that client to be onboarded. So you see that it's 6,971 microseconds here, and the respective gateway it is onboarded on, which is the same that we configured on 6300 too. And I will also show you the next client. So this is my Windows client, which has a client IP of 20.0.0.30, and the same details follow here as well for L4. As you can see, it is successful, and the gateway IP along with the latency. So next we will talk about how this works in case of a MAC auth. So I am trying MAC auth here along with the free radius server. So this I'm trying only on my Ubuntu client. So I'm just trying to ping the radius, the switch from here so that it talks to the radius server. And we will see if the client has been onboarded here using show port access clients. And you see that 20.0.0.31, which is my Ubuntu client, is onboarded with the MAC auth. And Here are my radius server details too. So it's resting on 20.00.32 and it's able to talk, the switch is able to talk to the radius server, so is the client. And now if I check the diag dump client inside basic output, you will see that the MAC authentication latency has also been captured here as a part of L2 onboarding. Yeah, so that's my Ubuntu client, and I see the MAC auth radius latency here under L2, and that's how the feature works in case of radius server configurations enabled. So that's pretty much it with the demo. So let's move to the next. So with that, we come to the end of this session, and please do join the Airheads community by scanning this QR code if not done yet.